part 3. In this video we're talking about how we can call smart contract functions and really make this website or web UI dynamic and actually make it work. Okay, so this is where we left off. So there are just web3 object. This is coming from MetaMask. For this demonstration purpose we will use MetaMask only, but if the same thing can be used with this given provider as well. Okay, so we need a couple of things if you want to call a smart contract function. First thing we need is the ABI, array ABI. ABI is an application binary interface, which is basically an array of these variables like this key value, key value, key value, key value, key value array. That's what we need. For if we want to call any particular smart contract, we need that ABI. For this demonstration purpose, I'll take this smart contract. If you want to have that, then EtherAuthority. So this is called a token smart contract. Basically, token smart contract is one kind of cryptocurrency. So I can transfer the token, or I can do any kind of things I want to do with the currency. This kind of smart contract. So I will call that function. This is contract address. Okay, let's start putting the variables inside our application. Okay, first thing we will need is contract address. This is the contract address. Then we will need ABI. To get an ABI, you can get it from, let's say this is Etherscan. Go to this contract page, then go to this code, the same section, and at the bottom this is the contract ABI. So you can get the contract ABI, which is a array of objects of all the detail about the smart contract. So we'll need that one. So copy this one. Now let me create a variable for that. So this is a whole array, and these are all the functions and variables and everything about the smart contract. So we can call all those functions and variables. We can use the variables and we can call the functions. Okay, so these are the two things. One is ABI and another one is contract address. So this is what two things we need. Okay. All right. Okay, so we have to go to the contract section of web3. So web3 ETH contract. Now if you want to call a method or a function, we have to use this one, myMethod.call. Okay, so first we have to initialize first the my contract object first. Methods. Yeah. So we have to initialize the my contract object first. Already met. Okay, ETH contract. Okay, so this is how we can initialize an object, my contract object. but first we need the from, which is the user who is the calling the contract. So we need that wallet address, and we will get that wallet address from MetaMask. So whoever is logged into the MetaMask will get that address. MetaMask injects web3 object by default. Okay, let's go one by one. So in here, first we'll check whether web3 object is there or not. It should, right? Okay, so we have this object. Okay, good. Once we have that object, we can get the wallet address by calling this. Okay. All right. So web3.eth.get accounts, it will give the account. So it will be, if you want to get the reference, then web3 eth get accounts, web3.eth.get account, get provider. Get accounts, yeah. So is this one. So if we can use this one, it will give the whoever is the logged into the MetaMask, we can get their wallet address. Okay, and in account, the first it will be an array. So the first index of that will be my account address. So if you can console that one. You can see that, so we are getting the user address. See, this is the user address, D19. So whoever is logged in to the MetaMask will get that address, D19. Now let's say if I want to, if I change this to this one, it should change this one as well. Right? It's 68968. See, it's 968. This one is changed. So this is how we can get the wallet address of the person who is logged into the MetaMask. Now we will initialize the my contract object, and it's there here, my contract. It's asking to go through. Okay, so this is the one to initialize the my contract object. Copy this one, use this inside this bracket. We can get it outside by doing async await, but we also can do this way as well. So in here we are initializing my contract object, and it's calling this function, and here we have to give the array API. So this is our array API, and second field is the from address. So this is it's a contract address. So we have to put here contract address. So array API and contract address, and in here from we have to put my account address. So whoever is the logged into the MetaMask will use that one here. We really don't need this. By default it will take whatever it is, but for now we really don't need that. Here only from is necessary, we don't need other things. If you want to check whether it's working correctly or not, you can see its output. You should get all the contract object, otherwise get an error. Web3 it contract is not a constructor. Nice. So it didn't work. Okay, there is some spelling mistake or something. Okay, it should be like this. Okay. See, here I used web3 Infura, which is the web3 object from the Robster. See this one. It's not using this one. It's not using. See the difference. This is another test I have written. Okay, so don't confuse this one with the one I'm writing here. So this is the web3 Infura. We are getting web3 object from Infura, and this is web3 we are getting from MetaMask. The reason why it gave this error is because both has different versions. This one has a different version, and this one MetaMask also injecting different version. So that's why they are not picking up. So for this our work purpose, we can use web3 Infura object here to interact with the smart contract. We can use whichever. I mean, if you are working with any different version of web3, it will work. So for this our purpose, I use here web3 Infura, but I have to first make the Infura object here. So same as this, I have to make the web3 Infura object first. Here or make it at the top. Okay, we already have it. Okay, now let's see what happens. There you go. We now have contract object initialized. Now we can call all the contracts functions. So as you can see here, there are lots of contract functions. We can call all of them. So this is the JSON interface ABI. So it get the value from ABI, array ABI. So there are 55 the functions we can call. So all these functions we can call, and we can, these are the functions of smart contract. So we can call all those functions and we can do all our things. Okay. So before I talked to you earlier, like there are two types of functions. One is call and one is send. Call is we read data from the smart contract, and another one is write. So read and write. Read does not cost any gas. Gas means it's a transaction fee. So whenever we write something on the smart contract, it's not free. They have to pay some gas. Gas is in the form of cryptocurrency. So they have to pay ether for the gas, right? So whenever a person do a write transaction, they pay gas, pay transaction fee. Okay, so we'll do couple of transactions, or I mean, we'll do couple of read and write from our script. First thing, let's say we want to retrieve what is the name. Name is one function we can call. So let's see we can retrieve this value in our script or not. So we have the script, we have my contract object ready. Okay, all we have to do is just call object method. Okay, so this my method, my contract dot methods dot name of the method and the parameters. If we can do this, and it will return the value. So let's do this. Copy this one. My contract dot method, these are the default keywords, right? Then we have to write the name of the method, whatever it is. Parameter, we don't have parameter at the moment, so we can just leave it as it is. Call, we can leave it as it is. This is their own keywords from my account. Okay, and then function and result. Let's see if we can get the result. Yep, we got it. See at the bottom, it's EtherAuthority. So this is the result we got. Um, okay, so well, yeah, that's it. I mean, we can call any function and get retrieve any information. Let's say we want to retrieve balance of. Okay, balance of this user, the one who is logged in. This user, if you can do here, if you can query from the UI, it's 0. Let's see first who has the balance. I think it's the first one. This one has the balance. Okay, if I can keep this one, so this address has value. See this value. So let's call this balance of with this address. Copy this one. Name of the function is balance of, and parameter is, because it has a parameter, so we have to put this address. Call everything is as it is, and it should show up the result. Okay, yeah, so we got it, right? Yes, 799 whatever. So this is all the information we are getting here. We should be getting in our script. This is read type of contract. Now let's talk about the write type of contract. Write means we writing into the smart contract, and it will require verification, I mean authentication from the sender, and it will cost gas. And what I mean, I'll talk to you in a bit. Let's say I have okay, D19. Okay, so let's say I have this much of tokens. So basically this is the balance of. Balance of means it's a one kind of variable into the smart contract, and the balance of. So this is one kind of variable into the smart contract, and it has a value of this. So I have this much of value. Now I want to transfer this to someone else. And for that I am calling the write function transfer. Transfer from number transfer. So it has two parameters. One is to whom I want to send, and the value. So this function let's call. Okay, let's leave it this one here. And for the write, okay, for the write type of transaction, we have to call this one send. So that's okay. So is this send type of transaction requires authentication. All right, let's do it. Copy, paste. Method name is transfer. They have two parameters. We want to send this to, let's say this one. We can put any address, right? We can send money to any address, right? And the second one is the amount. So let's say I want to transfer this much of tokens into this wallet. Send from my account address, right? And then function transaction hash. Let's see what we got. Transaction. All right. Here you go. It launches MetaMask prompt automatically to sign a transaction, to authorize a transaction, which is basically I has to confirm to transfer because it's calling a transfer function. So this MetaMask automatically picked up that we are calling the transfer of the token and just confirm. If I confirm, then it will trigger. See, this is the transaction hash. We output the transaction hash. Let's copy this and let's see what happens. We can put any transaction hash or address or something, anything on Etherscan. Click. Here you go. So I can see the transaction. The from is this one, to is the contract address is this, and the token was transferred from here to here and amount is this. Don't worry about this, is because it has a decimal point. So basically the amount was like this, divided by this one, because the decimal points we already have. This is the logic in the smart contracts. You don't have to worry about why this is happening or not all, but from the application UI perspectives, you got the confirmation. So here you got the transaction that the transaction has been broadcasted into the blockchain and transaction has been done. So and in here, if I can go to this token, this contract address, I can see this transaction 50 seconds ago. So this is the transaction happened, and these are other information like we can see the transfer method was called, and this is the address and value. If you can decode this one, then it will show exact value has been used. Okay, so we did the transaction. Basically in our application we did the transaction. All we have to do is just do the transaction and then handle this response. So sometimes it comes error, sometimes it delays or whatever happens, we can handle the whatever the response or result is coming. Like we can give ID into JavaScript element and we can give the value into the JavaScript application. So basically that's it. So in case of our application, this decentralized application, what we do here is just call this deposit. There is one function in the smart contract, we just call it, and let's say I call this, but I don't have that much at the moment, so it doesn't work. But let's see if I got this one, any token here. No, I don't have it any. Yeah, I got it. So let's see if I can click on this. So in background, it's just calling the same function as we did for our test purpose, and it will triggers the MetaMask prompt, and just have to confirm. And when I confirm, it sends the transaction to the blockchain, and at the same time it triggers this model pop-up box as well. So we can handle this type of user related experiences in our GUI, but this will happen. We can do we can handle the response the way we want. As you can see here, it will take a bit of time to confirm the transaction because in the blockchain it takes time to confirm the process. See, it happen. Once it does, it again sends the response that this one has been done. Okay, because there is two-step process, so they also trigger another part. So I have to confirm again. I can also check the status of the transaction into the Etherscan. So it takes a bit of time to confirm the transaction. Meanwhile, user has to wait, or we can design the UI in certain ways. They don't have to wait. It happens on the background and it updates when it's done. So we can handle the response any way we want to handle in the JavaScript. So basically, this is it. This is to call a smart contract. This is how we can create a smart contract object. This is what we created, a smart contract object, and we can call their function. This is the read function and this is write function. Write will require the authentication from the user because basically that's a real transaction, something changing in the smart contract. So there is need, it's required the user authentication, and anybody can read the data. So anybody can call these functions. So that's it pretty much. You can call all the functions into the smart contract, as I said earlier. You can call all these write functions and all these functions from the UI, and also you can call all the read functions from the UI, and the code will be exactly like this. That's it. This is how we call the functions. So thank you so much, and we will move on to the next video for we covered in this tutorial read and write for this calling smart contract functions, calling other web3 functions. We all also talked about this one. I mean, calling other web3 functions. These are the web3, and we can call all the smart contract and accounts and utility functions, all other web3 functions. So this is how we use this web3 into creating our decentralized application. There are so many use cases. So it's not only this, but there are so many other use cases of this. So thank you so much, and next tutorial video, next part, we'll be working on the real project, another real project where we will be handling the MetaMask integration more specific way. For example, if user don't have MetaMask, then what? How we can catch whether user is logged into the MetaMask, or how we can check whether user is on the correct network. Sometimes user might not be on the correct network. So we have to make sure that the user are on main Ethereum network or whatever network. So this is for the code we will be covering on the next video. Thank you so much, and